Welcome back, ladies and gentlemen. Today we are talking about simplifying when we're multiplying with a radical involved. So we got to remember that in order to add exponents, which can include radicals, right, as a fraction, we have to have the same base. So we could look at this and go, okay, maybe I'm going to have to do something with the 14 and the 17, but the problem is I'd have to rewrite this as 14 halves times 7 halves. It's not going to work. I'm not going to be able to do anything with those exponents because my bases are not the same. So what I can realize is radical 14 times radical, that's a real weird radical, but there you go, is the same thing as 14, the square root of 14 times 7, like quantity 14 times 7 square rooted, okay? So this doesn't really work, but this does. So if we take 14 times 7, that's actually, I can actually start factoring it, right? That's actually the same thing as 2. Why are you doing that? I don't know what's causing that every once in a while, but oh well. That's the same thing as 2 times 7 times 7, and I have 2 7s, or a group of 7s. So that means I can take it out, and it gets rewritten as 7 times the square root of 2, and I'm done. So 7 times the square root of 2 is the same thing as square root of 14 times square root of 7. Excuse me. That's staying in. Anyway. Getting old's not fun, folks. All right. We can use this same rule, but we have to remember the distributive property. Distributive property is going to say that I have to take this radical 5 and multiply it by each term inside the parentheses. So I'm going to take radical 5 times radical 3n, and I'm going to take radical 5 times radical 75n. Now here on this one, it's the same thing as 1 radical and then multiply the radicands. 5 times 3n. And remember, we had a subtraction in between, so we got to be keeping that. I forgot to write it because I usually add it at the end to remind myself where we're at. I just look at these as two different problems. So here, I get 5 times, well, I know 75 is a multiple of 5. And it is 10 is 50, 25, 15. Like all that thinking, the eyeball movement. All right, so I have a pair of 5s here. I can take that out. I don't have any pairs here, so I just do the multiplication. Sorry, here I don't have any pairs, so I just do the multiplication. 15n. I keep the subtraction. I take the 5 out. And I keep the 15n. Now, if I really wanted to complicate things, I could say this is my answer, but if I wanted to complicate it, I could see that this is radical 15n, this is radical 15n, so I could use the distributive property again to say if I take that out, I have 1 minus, that would be 5, wouldn't it? Yeah. 1 minus 5, because there was an invisible 1 in front of that. That's where this 1 came from. And 1 minus 5 is negative 4. There we go. So then, to rearrange it in the order I like, to have a number in front of any radicals or variables or exponents. And there's my final answer. So, while this is an answer right here, an answer, this right here, we would get the same answer, but it's the answer. In other words, this is fully simplified. We've been able to get rid of all operations that we're able to. So you do have to go the extra step, the extra way to do this. Now, on B, there's a little bit different of a way if we wanted to do it. And it's going to come from looking at this here. But we're going to look at it in terms of this. If we took this 75 before, we would actually have 3 times 25, and 25 is 5 and 5. So what we can notice is that this term right here can actually be written as 5 and 5 radical. I think that's the problem. If I hold out too long, it starts doing some other things. 3n. In this, we have net radical 3n minus 5 3n's, which actually, so if I rewrite it up here to make it apparent what I'm talking about, minus, oh, I wrote that 5 in the wrong place because I'm thinking 2 steps ahead and I shouldn't be. Be in the moment, Mr. Spees. So if I have this, and let's say I have x equal to radical 3n, then it's also true that now I have x minus 5x, which is equal to negative 4x, and I can plug it back in, and then I could multiply it by this radical 5 and end up getting the same thing. So remember, everything in purple is a secondary way of doing it. You don't have to have done it. It may have been better as a second video to add that in. I don't know. That's what I'm trying to find out. Remember, earlier in this chapter, we were doing 2 different videos. Now I've combined them into one. Tell me which one is easier to follow. I'm looking for that feedback because I want to have the most effective way to be able to talk to you guys and communicate this information. Let me know. And if you're a stranger on the video getting this because I had to make my videos public so my students could watch it, meh. I may or may not listen. In other words, if it's appropriate, if it's positive, if it's good feedback, I'm willing to listen to anybody in the world. If you're going to be a troll, oh well, I'm going to sleep good at night because I'm just going to hit the ignore button in my brain. All right. For the rest of you, for those in my class, you know how to get a hold of me. Do so, hand, neighbor, email, doesn't matter. Let's get this figured out so we can use this because this comes in and out. It comes up every once in a while. It's probably more calculus and higher level math, but it's still good to practice and learn because you will have to use it here and there in algebra. So, till next time, take it easy.